Good morning, and welcome to Works with 2023. My name is Daniel, and I'm the CTO of Silicon Labs. We make the wireless chips and software that connect your embedded systems to the internet. My life centers around this technology, and today I'm excited to talk about our connected future. To get started, let's take a look back. In 2011, two things happened. First, Ericsson published a landmark white paper predicting a whopping 50 billion connected devices by the end of the decade. Second, Apple launched the iPhone 4S, which was the first smartphone on the market with native support for Bluetooth Low Energy. I remember both of these well, as Silicon Labs was beginning to ramp investment in wireless connectivity. Ericsson's prediction was a big deal and really stretched the imagination. Smartphone adoption was still on the rise, and no one had ever seen wireless technology deployed at this kind of scale. Now, of course, they thought it was all going to be cellular, but we've learned some things since then. And Apple made a huge bet that personal computing devices would need to exchange data with embedded products on a scale never before seen. They wanted to share data continuously, serving as a hub of sorts for the apps that so many people were downloading. At that time, anything seemed possible, even connecting your cats to the internet. So what happened? Well, the IoT has arrived and is thriving. There are literally billions of connected embedded systems on the planet, and we're not too far away from hitting the 50 billion devices which at one time was so unthinkable. According to IDC, we'll cross that threshold sometime in 2025, just 2 years from now. I call that success from a prediction that's that big. And even in gadgets, internet-connected cat came true. And that's really so interesting. Think about it for a second. To get that cat online means 4 things must have happened. First, we need robust, highly reliable data networks. You have to be able to get data from point A to point B for virtually zero cost with high quality. Second, we need ubiquitous mobile computing. Everybody needs to be walking around with a computer in their pocket. That's the primary interface for people to the IoT. Third, we need limitless cloud computing. The idea that all that data can be stored and accessed at any time is now arrived. And finally, we need high-volume, low-cost chips at the far edge of the network. After all, putting your cat online can't cost $100. Back in 2011, before cloud computing, before wide-scale smartphone penetration, this was a stretch, to say the least. And the impact of what we're doing goes so much further than pet tracking. That this happens at all just shows the barrier to deploying the technology has come down so far that we're only limited by our imagination and creativity. Embedded computing is the largest, most constrained computing platform on the planet. And it's not a coincidence that the IoT is happening now. As different as they are, end markets like data center, PC, mobile, and embedded are linked, and it's worth it briefly to compare and contrast. Now, this is the largest computing platform, and together we deliver higher volume to more customers than all other segments combined. Our products deliver phenomenal technology at a lower cost for a longer period of time. The richness and diversity of applications and overall needs makes it one of the most interesting ecosystems out there. And maybe most importantly, it's going online as we speak, much later than the other markets. We saw data centers connect to each other in the 80s, followed by PCs in the late 90s to early 2000s. And then, of course, mobile went online the decade after that. Embedded markets are going online today, and this will have a massive effect on the global economy. We'll talk more about that later, but for many of us in the room, we will spend the rest of our careers developing generation after generation of new products for the Internet of Things. It's a really exciting opportunity, but before we go further, we need to talk about what does it really mean to be an IoT device. Now, it's really a simple idea. Take something, anything, break the air gap, and connect it to the Internet. We're taking everyday objects and doing just that. And I really see this as kind of 2 classes of devices. Some things are already rich embedded systems on their own right, with processing, sensing, transducing. The link to the cloud is really the final piece of the puzzle. Power tool on the page here is just one example. But there are other applications that make even a bigger jump, ones that previously had zero compute in them. But by adding the wireless connectivity, in many ways the cloud comes down. The product now adds compute and sensing, transducing. For devices like shelf labels or smart pallets, the cloud connection is the first piece of that puzzle. Regardless, once connected, these products take on an entirely different paradigm. Data continuously flows securely both ways from the device to cloud and cloud to device. They're now online, and they can do more than they ever could before. To me, this is the IoT. But in all instances, that connectivity is the key. That's what breaks the air gap. You're outing this foundational capability for dozens of reasons. Some of you want an improved user experience or use case. Others want increased safety and security, reduction in energy cost. Maybe you want to drive a new business model or revenue stream, or just increase your operational efficiency or drive down your insurance costs. In some cases, you may even want to ensure legal compliance. Now, Silicon Labs, we have thousands of customers, and long ago I stopped counting the new use cases. You just keep coming up with them. What I do know is the needs are real. The value is there. And that's why you're looking for new platforms that can do even more. Suppliers like us, like Silicon Labs, are there, aggregating the needs of the market and building these platforms. We've been in the business for a long time, starting with simple 8-bit processors and low data rate sub-gigahertz transceivers before smartphones even existed. And over time, we listened to you and built generation after generation of technology, a platform to address the needs of a massive connected embedded ecosystem. Today, with Series 2 products, the barrier to implement connectivity, security, processing, even edge intelligence has plummeted. Capabilities are bigger than we've ever had before. But we're not done. As you heard from our CEO yesterday, our next generation platform, Series 3, is in development. It'll bring even greater leaps of wireless, compute, security, and machine learning to the forefront as the IoT moves into mainstream maturity. So what happens now? Where is this all going? I'd like to explore that with you in 3 ways: impact, permanence, and pervasiveness. Now, these topics are all a bit overlapping, but they're worth exploring separately. McKinsey recently published a report estimating the impact of the IoT at $5.5 to $12.6 trillion by 2030. This represents anywhere from 5 to 10% of the global economy at that time, resting on the technology and products we're building here together. Now, these are just fantastically large numbers, and you may wonder where all that value lives and what it's doing. The report does a great job breaking down more than 10 settings and 10 use cases, but the simplified view is that the technology will go into every major end market and enable devices to be better than they could be without. They will be in our factories, in our work sites, in our cities, offices, in our home, and even our medical settings. The data moving on and off these end products will enable higher safety, efficiency, security, and ultimately productivity. At this point, we have gone so much further than tracking cat collars, although those things can be fun too. Here are 3 examples. First, energy utilities are implementing IoT technology throughout the grids. This started long ago with automated meter reading and has grown exponentially in recent years. From power plants generating electricity down to the circuit breakers in your office and home, everything is getting connected. They're doing this because the needs are higher than ever before. The decades-long trend of electrification continues, as evidenced by the rise of electric vehicles, which place extreme and new demands on the systems. A utility operator needs to understand in real time what is happening so they can manage the electricity grid for its highest efficiency and safety. Second, our understanding of health and wellness will transform. Not only will we be getting the advantage of monitoring and diagnostics once only available in clinical settings, we'll finally gain arguably the biggest insight of all, personalized health. Applications like glucose monitoring will not only save the lives of the insulin dependent, but for the first time will gain the ability to understand the complex linkages between genetics, environment, nutrition, and microbiota, and to do this at scale for everyone. This in-home monitoring will allow doctors to evaluate health and wellness down to the individual in a way never before seen. Simply stated, a physician and their patient will be able to address both disease and wellness together based on high-quality, personalized data. Technology like the ones we're building are essential to propel medical care forward. Finally, agriculture is adopting IoT technology in droves. There are more people on this planet than at any time before, and feeding them continues to be one of the most important activities driving our economy. Companies are implementing solutions to ensure a robust, high-quality food supply chain. One simple example is bees. Bee populations are crucial to our food supply chain. Farmers and beekeepers are installing hive monitoring systems to ensure the health of the hive, track movement, maximize honey production, and even more. Now, these are just 3 examples, but every industry globally is adopting IoT technology to propel their businesses forward. And once they do, there's no going back. I've asked myself why that is, and I've kind of come down to there's really just 2 reasons for this. The first is that a connected device unlocks value. There are many reasons for this, but it's best to show in a real-life example, like a power tool. Milwaukee Tools is a US-based manufacturer that has installed connectivity throughout their tool portfolio. By doing this, they're able to do so much more than they ever could without. But what does that mean? First, they're able to optimize the performance of each tool to the specifications needed for that day and job. They can program things like power, torque, duration, optimizing each trigger pull to get its unique job. This drives speed, efficiency, and safety for the worker on the job site. To make that real, here's a simple example. When you're installing a solar panel array for electricity generation, if you over-torque the screws as they set down on the panel, you can create microfractures in that panel. And over time, measured by months or years, the output of the entire array drops. By programming trigger pulls so that they don't over-torque, you make that array last longer. Beyond this, with Milwaukee Tools' wireless connectivity, they're able to track and locate the tools. Workers on a job site, workers who are getting paid a lot of money, very high-skilled, can quickly locate the tool they're looking for, rather than spending hours or minutes looking for it. Think about when you're building a building. That building may take 1 to 2 years to put together. Tools get dropped off at the beginning, picked up at the end. No one wants to spend time looking for that tool when the schedules are on the line. And these tools can even be locked through their app, dramatically reducing theft and even ensuring that only qualified workers are able to use that tool for the day. And the sensors embedded in these tools are able to remotely alert the user if repair or maintenance is required. Doing this increases worker safety, reduces unplanned downtime, and extends the life of the tool. No one wants a catastrophic failure of a tool for that day, and no one wants to pick up a tool that may not finish the job. Finally, the logging capabilities in the tools can be downloaded to provide proof of work. This is important for safety and compliance inspectors. A simple example is the crimpers used in connecting high-voltage cables together. There are specified clamping profiles of power and duration to ensure robust and safe connection. During inspection, the user can download the crimping logs and present to the inspector as further evidence of proof of work. The bottom line here is that a connected product is simply better. Businesses have figured this out and are rapidly adding these capabilities. And once they do, they move into a different phase. They move into a data-driven phase where they're generating value and are more reliant on that data than ever. And once a company integrates that data flow into their business model, their business operations, they simply cannot go back. This is the second reason. Today, no business can survive without a significant internet presence for things like sales, marketing, customer support, business development, and communication. This really is what the first wave of the internet was all about, connecting people to people and people to businesses. But for the IoT, we're doing something different. We're connecting the devices to cloud applications. There are 100 times more devices on this planet than people, and this new internet, this new way of thinking is transforming those business models. Let's walk through a couple of examples to make that real. Something as simple as electronic shelf labels are transforming retail settings. They started as a way to reduce the time spent updating pricing, allowing workers to spend their time on more higher value tasks. But once there, the shelf labels allow so much more. Retailers can implement dynamic pricing models, advertise discounts, and assist in locating items. Paradigms like omni-channel visibility between the online and physical store setting is hard to impossible without this kind of automation. Importantly, they're even able to minimize risk by guaranteeing price parity from the shelf to the register. All of this is made possible by connecting those labels to the cloud. Second example is in transportation. Now, transportation and shipping is also implementing this technology throughout the supply chain. This started by answering and asking a simple question: where are my things? That's really one of the killer apps in the IoT. But once those things are connected, you begin to want more. You want to know temperature, humidity, vibration, tampering, light detection. With all this kind of information at your fingertips, you can create a safer, higher quality, and ultimately lower cost supply chain. This makes for happier customers, lower insurance costs, less spoilage, and even reductions in theft. Third, in building and home security, we're seeing the adoption of additional IoT technology for faster and higher quality installation. No more running wires all over the house to detect the state of a door or a window. But with the new technology, you're able to reduce one of the biggest challenges in security: false positives. When security systems trigger, one of the biggest issues is the apathy of the customer or emergency services. The customer may not do anything about it if they don't believe it. And emergency services, well, they don't want to send a car out to a residence if they think the system has just failed, and it happens far too often. With more sensors, with higher compute, we're able to tell the difference between a pet and a person, or between a window shattering and a door slamming, or someone falling down. By adding more IoT devices to the home, the number of these false positives plummets, leading to a higher safety and improved emergency service response. Now, these are just 3 examples of industries that have adopted our technology, and they cannot go back. If you tried to pull this out of their hands, they wouldn't know what to do. So what we see is that the IoT will be everywhere. It will be pervasive. You're already surrounded by hundreds or thousands of CPUs each moment throughout the day. It's not just your computer and your phone. They're everywhere. And we're in the process of pulling all these CPUs online. The volumes are fantastically large. We traditionally think about segments in the hundreds of millions as being big, but the IoT has segments with volumes in the 1 to 10 billion range, multiple of them. Now, each of these products needs a chip and software, and they're all generating fantastically large amounts of data. They need to be deployed at scale and managed remotely from the cloud, pulling data off and putting the data back onto the devices safely and persistently. And when viewed through this lens, you can begin to understand how the IoT technology can be a foundational pillar, an enabler of growth in the global economy. But we're not done. We can't rest on our laurels here. We have more work to do in front of us than all the work to date. We're still in the early phases of the deployment of the IoT. And when prepping for this amazing opportunity to stand in front of you, I asked many questions, including what more do we need to do? Surely, waiting is not all there is. Across dozens of conversations and hours of research, 4 things bubbled to the top: accelerating software, securing your products, connecting cloud and device teams, and establishing and empowering data governance. And now I'd like to introduce Manish, who will talk about accelerating software.
Software is critically important to accelerate and scale the IoT to 50 plus billion connected devices, as Daniel just described. To support the IoT's incredibly diverse range of devices and use cases, we as an industry must adopt modern development techniques and tools to build advanced software into embedded applications. It's why Silicon Labs was the first to develop a complete platform, the right combination of chips, software, and tools purpose-built for the IoT. And we've turned software into a core competency. We're committed to delivering the industry's leading wireless IoT software platform that is scalable and easy to use. We want developers like you to be able to focus your time and resources on building innovative products, application-specific solutions to extend seamlessly across a broad range of hardware, ICs, and protocols. We know first and foremost, you want wireless that just works. A key element of any IoT platform is a broad software portfolio of wireless protocols such as Bluetooth, Wi-Fi, 15.4, Z-Wave, Wi-SUN, Sidewalk, Matter for the connectivity solve. Multi-protocol, coexistence, and interoperability are increasingly important. Second, application-specific middleware is needed to enable the diverse use cases on our heterogeneous compute engine, like the MCU, the IML, the hardware accelerators, and to bring more intelligence to the edge. A real game changer is support for real-time operating systems. With more compute and flexible memory at our fingertips, it's time to embrace the RTOSes of the world as the foundation for software development in embedded devices. RTOS makes products scalable, maintainable, more secure, and portable, which is exactly what is needed for the IoT to flourish. And of course, developer tools and community support are essential to make a software platform very easy to use. As you heard in yesterday's keynote, Silicon Labs is working on exciting advances to our platform and Simplicity Studio to meet your needs, support the acceleration of software development and the success of the IoT. With great software, we can advance the capabilities, interoperability, and security of embedded applications and scale the IoT.
And now we have Sharon, who will talk about securing your products. The stakes have never been higher for securing the Internet of Things. Economies are increasingly interconnected, and connectivity for everything around us is fundamental. The boundaries between digital and physical blur, and that's an amazing thing for innovation and economic growth, as well as societal benefit. On the other side of the equation, threat actors are becoming increasingly more sophisticated by harnessing AI and automation to escalate scale and deepen their attacks. The IoT has been a prime target for hackers for many years, but as connected devices become more pervasive than ever, the opportunities in terms of vulnerabilities and attack surfaces grow at an exponential rate. Around the world, governments are starting to recognize the urgency in addressing these concerns. We're seeing the emergence of regulations based on industry standards like NIST 8259 and ETSI 303645 in EMEA. Just recently, the U.S. government launched the Cyber Trust Mark program, underlying the need to provide clear information to consumers about the security of their Internet-enabled devices. Nowhere is the danger more apparent than cyber attacks targeting IoT devices in critical applications like medical and industrial, with their potential for disruption and devastating losses. The importance of safeguarding IoT devices has reached a critical point. Security is most effective when it starts with the silicon as foundation. We provide the hardware foundations of trust with our industry-leading Secure Vault technology and our continuing efforts to certify our products to the highest standards, including the ARM PSA Security Architecture or PSA Level 3 certification. Our comprehensive software solutions further protect all aspects of IoT solutions and are designed to help you adhere to current and emerging regulations and standards. We also secure and manage our entire supply chain to ensure authenticity and integrity of our semiconductor products from fabrication to final delivery. Our goal is to be your partner in navigating the complexities of IoT security. We are committed
to working with your development and design teams hand in hand to implement the best security capabilities in the market in the most cost-effective manner. The time to secure your products is now. Together, we can create a safer, more resilient IoT industry. Thank you.
Next up, Mike will talk to us about connecting your embedded and cloud software teams.
When we think about what makes up the IoT, or the Internet of Things, what are we talking about with these things? Really, they're embedded systems. Systems made up of customized hardware. Think a microcontroller, a microprocessor, some sensors and actuators, all running specialized software. Things historically isolated and self-contained, but now are being connected together with each other and with centralized servers or the cloud. This has in effect changed the paradigm from isolated systems to a distributed computing system made up of many end nodes performing their localized control and sensing operations, collecting and processing data, but now communicating, taking commands from and sharing data with gateways, mobile apps, and servers over public and private networks. Cloud services are bringing together these increasingly sophisticated end nodes. Embedded systems and software are getting more and more sophisticated and more complex. Technological advances are making it possible to do more at the edge. Think about AI, ML, for example. And the cloud is adapting along with these advances in embedded capabilities. The value of the IoT is realized through the smooth operation of this entire distributed system. Each component of the IoT needs to function effectively and efficiently. So it only makes sense to bring together the developers from the cloud side and the embedded side to help solve these problems together, to achieve efficiency, to work to solve things like device onboarding, device and firmware management, security at the edge, optimizing power. So bringing these teams together will not only help to accelerate time to market, but also to maximize the benefits of the IoT.
Finally, Juan will talk about data governance.
Hi, everyone. My name is Juan Cicada, and I'm the principal scientist and the head of the AI lab at Data.World. Data.World is the industry's most used data catalog platform, providing data governance, data discovery, and data ops applications. So why data governance? IoT generates massive amounts of data. The question is, are you enabling the safe usage of data? I like to think about data governance as two parts. The first, defensive data governance. Let's make sure that bad things don't happen. Consider the analogy with brakes in a car. Why do you have brakes in a car? So you can slow down when needed. Data governance enables accuracy. I want to make sure that users understand what the data is about. Data must have clear definitions and policies so users understand how it should be used. Data must have its lineage to understand the flow and the provenance of the data, where the data is coming from, where the data is going, how it's being shared, how it's being used, and by which applications. Data governance makes sure that organizations deal with compliance and regulations effectively in order to make sure bad things don't happen with the data. At the same time, we should strive to have offensive governance. Let's make sure good things do happen with your data. Back to our car brake analogy. Why do we have brakes in a car? So we can drive fast safely. Let's keep track of the usage of the data, identify demands, identify opportunities that could lead to even new revenue streams. This is the opportunity to start treating data as a product and understand the consumers, the use cases, accountability, expectations. These data products can be available on a marketplace, so they can be discovered and used by consumers. In this era of AI, data and knowledge are at the center of your organization and are connected such that good things can happen. To conclude, data governance enables a safe usage of data.
If we can accelerate software, secure our products, connect cloud and embedded teams together, and empower data governance, I'm confident we'll take the IoT to get to the next level. Taking a step back, the IoT is bigger than I ever thought it could be. Getting into this business was simply about getting embedded systems to talk to each other. But here we are, rapidly approaching a world where the IoT is a driver of the overall global economy. Now, I look forward to hearing from you and where you're going to take this next. Thanks for the opportunity to speak to you today.